All right, folks, let's talk about these three molecules. This is a common thing that IB likes to use organic molecules for, to talk about shapes and bond angles. So they may show you a structure and say, what is the shape, the geometry, and the bond angle around carbon number 1 or carbon number 10 or whatever it happens to be. You look at the diagram, it'll be labeled, and you look around that particular carbon, and you see how many things are bonded to it, and determine what the shape and bond angle would be. So these are pretty straightforward, but they're all just two carbons. So what's the geometry around the carbons in ethane? Tetrahedral. Yeah. They've got 4 things bonded to the central atom. What's the bond angle for a tetrahedral shape? It's not 90. 109.5, yeah. Now, how do you know that? I just realized in first period that I never talked about why that is. It's 360 divided by 4. Okay? That's where that comes from. All right? So if there's 4 things around it, that breaks up the 3D space around the carbon into 4 equal spots, because we want them to be as far away from, those bonding electrons to be as far away from each other as possible. Yes?
But isn't 360 divided by 490? Yeah.
Is it?
Yeah.
Oh, then I'm wrong then.
Oh, I got it right.
Then I'm totally wrong. Sorry. How does it not work for the tetrahedral then?
Because maybe one side has more pressure on the other.
No. It's just, that doesn't make sense. You're right. It should be 90. Because it works for the 2 and the 3. I don't know. Yeah, I have to think. I don't know geometry well enough to know why it doesn't work or what the number would be for the 4. It's 109.5. Now, in the mark schemes for, so just ignore everything I just said. In the mark schemes for like the bonding test, which I have not finished grading, so I will give that back to you on Monday. It does accept a range from like 108 to 111 or something like that. So if you forget the 0.5, you still get the point. If you put it round it up to 110, you still get the point. So, but you still should have it memorized. Ethene, what's my geometry around the carbon? Trigonal planar. Yeah. So there's 3 things around the central carbon. Remember that this is a skeletal structure. This is a stereo structure. This is a chemical skeletal structure. Each of these spots where things are bonded are carbons. And so there's 3 things bonded to the central atom. It doesn't matter that one of them is a double bond. It's still going to split the bonding domains in 3, the space into 3. And so we're going to have a trigonal planar with what bond angle? 120. All right, and ethine, because it doesn't have a lone pair, because the carbon has 2 hydrogens and another carbon bonded to it. There's only 3 things bonded, and there's no lone pair on the carbon. That's what the skeletal structure is. It leaves out the carbons. In this case, it puts the hydrogens in because it's the end of the molecule, okay? And it's only just 2 carbons. They wouldn't just put this. I mean, that would just, it wouldn't be as, yeah. But for longer molecules, they might put something like that, and you wouldn't even see the terminal hydrogens. Yeah. All right, so ethine, again, we've got 2 carbons here. So what's my geometry? Linear. And the bond angle? 180, yeah. Right, because 360 is just in a plane. Yeah. All right, I'll figure out geometrically what's going on some other day. All right, so that's the kind of thing, again, that you might be asked to determine from a skeletal structure or from some other kind of structure on the test. All right, you can take these on your way out if you want them. I have a practice test from 2022. Paper 1 and paper 2. There was no paper 3 last year. What? Paper 1 and paper 3 are the same day. Paper 2 is the second day. Yes. I will give you a paper 3 at another time. I just don't have it right now. It'll be from a different year.
Will the grades for the IB test show up on college boards? Even though they don't.
No. You'll log into your IB account with the thing that I gave you on your testing ticket, and with the number and the PIN. Yeah. Okay. So yeah, it's a totally different system, totally different website. Yeah, not on College Board. Okay. This is a secure test. We had to pay for it. It is not available, or it should not be available easily online. We paid for it, and the school district said, yes, we are not going to just share it everywhere. So I need you to promise that you're not going to share it everywhere. So in order to take copies, I need you to sign this statement that says that you will not share it with anyone outside the class in any shape or form. You will not copy it, scan it, photograph it, display it, discard it. So you're not going to throw it in the trash or the recycling where somebody could pick it up and then put it on the internet. Or in any way distribute it, which means that you're going to return it to me by the Monday after the exam. So I want it back. And when I get it back, I will check off your name. Yes. You can write all over it. Yes. It's just for me to know that you kept it in your possession and are returning it to me. Okay? So on your way out, you can take, this is obviously, I didn't print one out for everybody in the class, but there should be plenty for anybody who's testing. And there should also be some for some HL students if you want to do this as well. This is a separate test from the one that I'm offering tomorrow morning here between 9 a.m. and 12:30. I will have a paper 3 available. We haven't covered the option material yet. We'll do that next week. So you may decide not to do the paper 3, which is fine. Or you may decide that you want to just look at it, which is fine too. It's kind of a choose your own adventure. Tell me what papers you want to do. If I have to have 10 different start and end times on the board, I'll do it. So that'll be first. The first one will be available tomorrow. I'll also, if you want to come in after school, I know some folks said they were more available after school. That's fine. And then this is a separate test with different questions that you can take home and use as you wish. If you want to browse through it, that's fine. If you want to use it for self-timing, that's fine, in lieu of coming in for a mock test, however you want to do it. Okay? Any questions about that? Yes?
The test tomorrow morning?
Yeah.
Is it
It'll be right here.
okay?
9 to 12:30, which I put all the info in the in classroom and an announcement. Okay. All right. All right. So going back to our yes. I'm sorry. What about? Yes. Tomorrow's a Saturday. Yes. Right. No. Yeah. People who aren't testing, I still need you to work on this packet that we're going to that we started going over yesterday and we'll continue with today. And that'll be a practice prep assignment, and then I'll also give you some question bank questions as a take-home test, basically, next week. Today's Friday. Yep. All right. So we talked about how IUPAC has kind of the authority over chemical nomenclature, and that's what IB wants you to use. There are lots of different naming systems that have changed over the years and been different in different places and times, but we're going to use the IUPAC nomenclature. So to start off, remember that the first thing you want to do is find your longest carbon chain. And you're going to the naming of the substance is going to be rooted in the length of the carbon chain. And you're going to use these roots to name that. So methane is 1 carbon with hydrogens around it. Ethane is 2 carbons with hydrogens around them, etc. So that's going to be the root. And like I said yesterday, it's unfortunate that these first four are different than what you're used to, the mono, di, tri, tetra. You have to learn new ones, meth, eth, prop, and but. But everything after that is normal. You can also have alkyl groups that are branched off of a main chain that then use methyl group or ethyl group, depending on how many carbons there are in the branch. So, how do we figure out how to name a structure? First thing we need to do is find the longest continuous carbon chain. Now, in this example on the board, I'll try to move it up because it's a little hard to see. There's really two possibilities. Okay, so I've got the chain that's highlighted. That's 1, 2, 3, 4, 5, 6, 7. I could also choose 1, 2, 3, 4, 5, 6, 7. Any ideas on why I would choose this version instead of the straight chain? Wiley? It's not actually. This is 7 and this is 7. JB? Yes, it's because of this. So we want to have just single chains coming off of our main chain. If I use this as my main chain, then I have a branched thing coming off of it, and that makes the naming more confusing. All right, so I'm going to choose this. What's the root name for this going to be if I have 7 carbons? Hept, yeah. It's going to be hept, not sept. Yep, okay? So this is going to be a heptane, okay? The root is going to be a heptane. I know it's an ane because I can see that in the straight chains I have just CH2s, which means our carbons are just single bonded to each other. None of them have lost a hydrogen to make a double bond. Also, it would show a double bond. So this is all single bonds, so it's ane. So this is going to be a heptane. But I'm not done because now I got to talk about all the things that are bonded to it, okay? So now I have to figure out the subchains, the branches. And each one of them, I have to identify them as some kind of alkyl group. If it's just one carbon coming off of the main chain, it's a methyl group. If it's more than one, it's the number of carbons. So this is a propyl group because there's 3 carbons coming off of the main chain. So I have 3 methyl groups and 1 propyl group coming off of the main chain. But just knowing that doesn't tell me where they're coming off, so I have to go further. So what I have to do is number the longest carbon chain so that my branches are as low as numbers as possible. Did I put that here? No. Let's number this. I can start numbering from this end, or I can start numbering from this end. It does matter, because the number of the carbon is going to tell me where the branches are. And I want those numbers to be as low as possible. Yes? That's right. That's right. So this way I've got 2 3s, a 4, and a 5. If I do it this way, it's going to be 3. Here, let me just rewrite it. If I do this as 1, 2, 3, 4, 5, 6, 7, then I've got a 3, a 4, and 2 5s. All right? Doing it the blue way from left to right gives me the smaller numbers. So that's how I decide where I start numbering it. It also depends on if you have different functional groups also take priority, but you're not going to need to worry about that at this time. So you're going to number it based on giving things the smallest numbers. Okay? I'm probably going to have to come back to this slide again because I think I have this set up differently. All right. And then this is a different example, but when you're naming, you're going to, and you have different groups like the propyl and the methyl in the previous one, you're going to put them in alphabetical order. And you're going to number the groups. So you're going to have number dash the branch, and then if there's multiple different kinds, you're going to put them in alphabetical order, ethyl before methyl, methyl before propyl, etc. And then if you have two methyl groups, you're going to use dimethyl, and you're going to put numbers in front with commas. I'm just going to show you on that first one how this is going to work. So I have 3 different methyl groups and 1 propyl group. So methyl is going to be the first, the one I'm going to use first in the name. So I'm going to number 3, 3, 5. Trimethyl. That's telling me that I have 3 methyl groups, and there are 2 of them are on carbon 3 and 1 of them is on carbon 5. And then 4 propyl, because this is a 3-carbon propyl group, heptane. That's my group, yes. Because it's 3, 3, 5. So there's 1 on the 3, there's a second one on the 3, third carbon, and then there's 1 on the 5 carbon. Yeah, so that's why you write the 3 twice, because there's 2 methyls on that third carbon. Good question. All right, this is probably more complicated than you'll have to deal with. Okay. So again, the groups, the functional groups, whether they're alkyl groups or chlorines or fluorines or whatever, would be, trichloro if there were 3 chlorines. If there was just 1, it would just be that number of the carbon and then chloro, and it would go, again, in order. And so the alphabetical order is for the base, so not the tri, but the meth, for the methyl groups. Yes? That's where they are. So this is we're using the blue numbers here. That's where they are on the long carbon. So we know we have a heptane, and then the third carbon and the third carbon has 2 methyl groups, and then the 5th carbon in the chain has another methyl group. And then the 4th carbon in the chain has a propyl group coming off. Okay. Yes? Because if we did it, let me go back, and if we do this, then what I have as branches are methyl, methyl, and crazy branched thing. I don't want that, all right? I want as many groups coming off of the main chain as possible. Now, that's something to point out, is that sometimes they will give you a structure that looks something like this, where it looks like the straight chain should be the longest one, but it's not. So you have to check yourself. I've seen questions in Question Bank where they have a branch where the branch is actually longer than what it looks like the base should be. Yes? What? No, because then it would be attached at the end. So having it attached in the middle makes this not viable as a branch. Yes, Grace. Like another methyl group coming off here? Yeah, so that would be a CH. Yeah, then you wouldn't get a question like that. Okay. Yeah. There are ways of dealing with that, but you're not going to have to deal with that. Yeah. Okay. All right. So again, the position of any branch or functional group should be on the lowest number carbon. So this is a situation where we've got 8 carbons and one of them has a methyl group. We're going to number it so that that methyl group is on the lowest numbered carbon as opposed to the highest numbered carbon. Right? So whatever the branches are, you want basically the sum of those numbers, if there's multiple of them, to be as small as possible. Okay, again, if you've got something like ethyl and methyl, the ethyl goes first because E comes before M. In the example that I just did, even though it was trimethyl, M still comes before P, so it goes before the propyl. Why is there what? That is a typo. I don't know. Okay, so comma to separate numbers, hyphens to separate numbers and letters used for the subunits. If it's like 3-ethyl, 2-methyl, you don't need a comma. It's only if you have 2 of the same type of substituent, that you use a comma, and then the di, tri, tetra, etc. So this is a 3-carbon chain, CH3C, CH3. It's got 2 methyls on the outside. It doesn't matter which way you number it because it's the same thing in both directions. It could be a 3-carbon chain here with these being the 2 methyls. It looks exactly the same. If you circle it around, it's exactly the same molecule. So this is a propane because it's 3 carbon, it's the longest chain. And then there's 2 methyl groups on there. So we have dimethyl, and both of those are on the central carbon, which is carbon number 2. So it's 2, 2 hyphen dimethyl propane. Okay. All right, so again, if we have multiple methyl groups or chlorines or whatever, we use mono-di-tri-tetra. Don't ask me why. I don't know the answer. Yes? Lowercase, yeah. Jacob? Do you have a question? Or okay. And then if you have this actually ignore that because that's kind of changed. I will post these slides. I'm sorry I haven't posted the slides and the videos yet. I will do that this afternoon. This also just kind of sums it up. So if we go then into your packet, into number 2, so this is where we can start going between the condensed structural formula, the structural formula, and the name. And so some of the questions are going to ask you to go from condensed structural formula to structural formula. Sometimes it's going to go the other way around. So let's look at this first condensed structural formula. We've got CH3, CH2. If you get in the habit of recognizing that CH2 is just a carbon in between 2 carbons with 2 hydrogens on it, generally speaking, right? If it's in the middle, that's what it's going to look like. It's just no double bonds there. Generally, it'll tell you if there's a double bond, but not always. So CH2, CH, CH3, meaning that this carbon has a hydrogen and a methyl group. And then a CH3. Nope, doesn't matter, because we can just flip it around. There are going to be situations when we have double bonds where it is going to matter. But yes. Yeah. So yeah, it generally, if it's in parentheses like this, it generally means that is a group that's going to be attached to the previous carbon. Yes, but then it'll have a functional group or something on it because it won't have 3 hydrogens, right? So it'll have something there to go along with it. You won't, the end of the group will never be in parentheses. Yes. Right. Yes. Yes. Okay. So good point. There is a section where, sorry, I need to go back to, yeah, let's cross that out. So, for example, pentane. All right, this was on your front page, right? So you've got CH3, CH2, 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 CH3. All right. In that situation, the condensed structural formula can be written like this with parentheses and a subscript outside to say there's a chain of CH2s. And I don't have to write every single one of them. You're not going to do this for something like ethane where there's just two CH3s. All right, you're just going to leave it like that. But when you start getting into these longer and longer molecules, rather than writing out as CH3, CH2, 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 CH3, what we're saying here, when there's a subscript, is that we have a chain of stuff. If there's no subscript, what it means is that that is a substituent branch group off of the previous carbon. Okay? Yes? I mean, it's sort of, there's not a hard and fast rule of when you start doing that. It's like when it becomes awkward to keep writing it out. So you wouldn't do it for propane because you've only got one CH2. You could do it for butane, but it would be almost the same to write out another CH2. Once we start writing out a bunch of them, then it makes more sense to put them in parentheses and put the subscript there. Okay, so thanks for asking about that. You could write it out this way. There's nothing wrong with this. This would be an acceptable answer for condensed structural formula, but this would also be an acceptable answer, and it's a little bit shorter. Okay. Questions? Okay, can I move on? Okay. All right. So here is, so in this case, we don't have a subscript here, so this is not a repeating chain. Plus, it's a methyl group. I couldn't have repeats of methyl groups in the middle because they wouldn't be able to stick to any other carbon. So the fact that it's a CH3 is one clue, and the fact that there's not a subscript after it, after the parentheses, is another clue that this is something that is bonded to, that is coming off of the previous carbon. Okay. So this is my full structural formula. Now, how am I going to name this? Take a minute to write out a name for this substance if you haven't already. Remember that you're going to number your carbons, decide whether the ending is ane, ene, or ine, and then use numbers and groups to name any substituent branches. All right, so Jamie, what do you have for this?
I have 2 methyl butane.
That's correct.
Let's go. Just kidding.
Now, huh? It was off what? Oh, yeah, for multiple subgroups. But the butane, this is the root. So the root always goes at the end. So butane is the root. We've got 4 carbons. And honestly, you could number them 1, 2, 3, 4 with a methyl group, or you could make this the one and this the methyl group. Either way, it doesn't matter in this case. All right, so you could name this carbon 1, and this would be the methyl group. It's, in both cases, it's still the methyl group is coming off of carbon 2. Okay. All right. Now, when you were drawing these structural formulas, instead of writing out all of the hydrogens on the substituent groups, you can write this as CH3. If it's a group, you can write this as CH3, okay? Because otherwise the hydrogens start running into each other and it just gets really annoying. So if it's a branch, you can write it sort of in a more condensed version. So here's a methyl group on this one, and then I have CH, and then I have 2 CH3s. In this case, I can't have 2 CH3s in a row because that's too many hydrogens. The carbons aren't connecting to anything. So what that means is that I have a CH3 up here, and I have a CH3 down here. Okay? Now that is a way of showing this, but it's actually kind of not the best way of giving a condensed structural formula for this substance, because rather than having this be the end of the chain with 2 methyl groups on it, what really should happen is one of these 2 should be the end of the chain. Yeah? Yeah, right, exactly. That's what I mean. So rather than having this hydrogen here, it would be CH3, It's just a weird way of writing, this is a weird way of writing this, this formula. So what I would do here is I would write CH3, CH3, and then this would be also a CH3, CH3. I feel like this is a better representation, but you'll notice I was able to get there from this. So, you know, no one's gonna like, I haven't seen anything where they ask you to write a condensed structural formula and there's like 2 right answers like that. Yeah. 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 Yeah, but that wouldn't be 2 CH3s. It would be CH2CH3. That would be an ethyl group coming off somewhere. Okay? That's why I don't like this, because this is you wouldn't have something like this. It doesn't make sense to me. But in any case, now we have this structure. Okay? So now, what is the name of this compound? Yes, Leia. Yeah. Yeah, I rearranged it because you would count the longest chain. So even if this CH3 was down here, we would count the chain as bending down or bending up. Yeah, Natalie. Yes. So we've got our 4-carbon chain, and then we've got 2 methyl groups. Now, this is another situation. This happens with the smaller ones, with the butane and the propane and stuff like that. It will often happen where it doesn't really matter which way you name the chain. It's going to be the same thing. If I start from here, it's still 2,3 methyl. If I start from over here, it's still 2,3 methyl butane. When you get into longer things like pentane roots, then you start having to worry about the numbers more. Okay. I want to skip the next one the one after here, the C2H5, that's an ethyl group. So there are two ethyl groups coming off of this carbon. And then there's a methyl group coming off of the next carbon. And then there's two methyl groups coming off of this carbon. Again, I'm not super fond of this way of showing the condensed structural formula, but you can get to the structure from the way they're doing it, okay? But you start being able to recognize, okay, a CH3 is a methyl group, a C2H5 is an ethyl group, and going accordingly. All right, that's what I have right now. I will post a key for this over the weekend, yes. Yeah, it is. One of the ethyl groups is going to be the end of the chain. That's why I'm not, yeah. I like this packet because it makes you do the transitions, but there's things I don't like about it.
Is it possible for it to not be on the end, or is it going to always be on the end?
You're always going to find, wherever you end up putting it with the condensed structural formula, are always going to go back and find the longest carbon chain. So, yeah,
But
yes.
saying with you add ene, that's not correct, right?
Ene for double bonds.
Yeah, but
So
there's
if there's a double bond.
Yeah, if needed, but none
Yeah.
of these have double bonds, so it's fine, right?
So let's see.
Or I guess they could. Okay, they could.
Yeah, they
Okay.
could.
They just don't.
Yeah.
You don't have to write out the double bond.
Right. So a lot of times the condensed structural formula will write the double bond in, but not always.
Okay. And
Yeah.
then, And then you just have to assume by the number of hydrogens.
Exactly. Yeah. All right. So feel free to sign out practice tests up front there about the warm-up table. So the questions all end up in question banks. So I have been very careful this year to not use any questions from the 2022 test. So these should all be new questions to you. They do reuse them. I have seen ones from multiple years that are like only slightly different from each other, worded differently, exactly. Also, every year has 2 time zones that they give the exam, and those 2 time zones have to be different because theoretically someone from time zone 1 could have, their Google glasses or whatever and be taking pictures of everything, uploading it, and then 6 hours later somebody gets to look at it beforehand. So, yes. There are reasons why these things are so expensive. I don't necessarily think it's, I have mixed feelings about standardized tests.